Hi, it's Rob. Welcome to this video in the Cumulus Cycles Raspberry Pi playlist where we'll build an Arduino-based autonomous obstacle avoiding robot. To follow along, you may find it useful to view two of my prior videos, Arduino Getting Started and Assemble an Arduino or Raspberry Pi compatible robot chassis kit, since this is the chassis we'll be using to build the robot. I'll add links to them in the description below if you're interested. Now, to follow along with the build, in addition to a chassis, you'll also need a few other components. First, obviously, you'll need an Arduino, and I'll be using the Uno model. You'll also need an L298N motor drive controller, a servo, and an ultrasonic sensor. To get started, I removed the 4 AA battery holder, as I'll be using a different power source for this build. Then, I mounted the L298N to the rear of the chassis and used some standoffs to raise the board off the body a bit. Flipping the chassis over to look at the undercarriage, I mounted a 9-volt battery holder, then I ran the positive lead from the battery holder to one terminal on the power switch and attached a lead to the other terminal on the power switch and passed it up through a hole in the chassis. I ran the negative lead from the battery holder up through a hole in the chassis as well. Now, flipping the chassis back over, we could take a look at the wiring. However, before I get into the details of the connections, I want to mention that I've provided a link to an excellent video on how to control DC motors with the L298N and an Arduino in the description below. This video is less than 6 minutes long, and it is well worth the time to pause this video here and go watch the video at the link provided. Okay, getting back to our build. Here, you can see the positive and negative battery terminal wires I passed up from under the chassis. I connected the red wire to the 12-volt terminal on the L298N and the black wire to ground. Then, I connected the leads from motor 1 to the out 1 and out 2 terminals on the L298N, and the leads from motor 2 to the out 3 and out 4 terminals. Finally, I connected a white jumper wire to the L298N's in 1 terminal and a gray wire to the in 2 terminal to control the direction of motor 1. Then I connected a purple wire to in 3 and a blue wire to in 4 for motor 2. Now, with the motors connected, we could focus our attention on the ultrasonic sensor and the servo. I attached the ultrasonic sensor to an angle bracket using some super glue, then attached the bracket to the servo arm. I wasn't sure if this was the final position I wanted to mount the servo in, so as you can see in this image, I attached it to the chassis using a couple zip ties for now. I then passed the wires for the sensor and servo under the chassis, then up through a couple holes back to the top. Now it's time to mount the Arduino to the chassis, and to do this, I used a couple standoffs to raise it above the L298N. With the Arduino mounted, I connected the wires from the L298N's in 1 through 4 terminals to pins 4 through 7 on the Arduino. Then I ran a black wire from ground on the Arduino and a red wire from 5 volts to the breadboard to power the servo and the ultrasonic sensor. On the servo's connection terminal, I attached a black wire for ground, a red wire for power, and a yellow wire for the signal. Then I ran the ground and power wires to the appropriate rails on the breadboard and the yellow wire to pin 10 on the Arduino. Finally, for the ultrasonic sensor, I ran power and ground to the breadboard, then the blue wire on the trigger pin to analog 1 on the Arduino, and the green echo pin wire to analog 2 on the Arduino. And that's it for the connections. So let's take a look at the code. Okay, looking at the sketch, we'll see I started by including 2 libraries. The first is the servo library, which is included by default in the Arduino, and the second is a new ping library, which we'll use to interact with the ultrasonic sensor. We'll need to install this library before we push the code up to the Arduino, and I'll show you how to do that after we review this code. Here, I've declared constants for the 4 motor pins, 2 for motor 1 and 2 for motor 2. Then I have a constant for the servo pin, and then the left, center, and right positions in degrees. So the center position is 90 degrees, and the left and right are offset from the center. The ultrasonic sensor's trigger and echo pins are analog pins on A1 and A2, and then I'm defining a max distance of 200, a boolean to determine whether the car is moving forward or not, and then an initial distance of 100. Here I'm calling the sonar function on the new ping object, passing it the trigger pin, the echo pin, and the max distance, and then instantiating an instance of the servo motor. If I scroll down and open up the setup function, we'll see I'm setting the pin mode for the 4 motor pins to output and then attaching the servo pin to the servo motor. These lines of code are just checking the positions of the servo to make sure we have a full sweep. So I'll start in the center position, then after a delay, check the left position, come back to center, move to the right, and then back to center. Finally, after a delay, we'll call the read ping method, which will set the distance. If we look at read ping quickly, we'll see that after a short delay, it will call the ping centimeter function on the sonar object and return the value in centimeters. If the value returned equals 0, I'll set the centimeters to 250, which is greater than the max, so the car can move forward, else I'll just return the value that was returned from the ping. In the main processing loop, we'll see I set initial distances for left and right. Then after a delay, I'll check to see if the distance is less than or equal to 20. And remember, the distance is the value we set on the first calls to the read ping function. If the distance is greater than 20, the car will move forward. And the move forward function just checks to see if we're not moving forward. And then if that's the case, we'll set moving forward to true, then set digital right to high for motor 1 and motor 2 forward, and to low for motor 1 and motor 2 reverse. If the distance is less than or equal to 20, then we'll stop moving, which just sets digital right to low on all the motor pins, then delay and move in reverse, which is just the opposite of what we do to move forward. Then stop moving again and look right to get the distance and left to get the distance. And look left just moves the servo to look left, then calls read ping to get the distance, recenters the servo, and returns the distance. Look right does the same thing, it just turns the servo to the right. After we get the left and right distances, we'll check to see if the distance is greater than or equal to the left distance, and if it is, we'll turn the car right, stop moving, read the ping, and then come up and go through the loop again. And remember, as long as the distance is greater than 20, the car will move forward. So that's it for the code. So let's jump into the Arduino IDE. Okay, and like I said previously, before we push this code up to the Arduino, we need to install the new ping library. And we could do that by clicking on Tools, Manage Libraries, and then search for new ping. I already have it installed, but you could go ahead and click the install button if you don't already. And once it's installed, we could go ahead and push the sketch up to the Arduino and test it out. Okay, so I've pushed the code up to the Arduino and I'm ready to test it out. The car doesn't move well on the carpet due to the front caster wheel, so I've propped it up here to get the wheels off the table so we can give it a test. Right now, I have power going to the Arduino from my computer, but I placed a 9-volt battery on top of the chassis that I can use for external power if needed. And as you'll recall, the L298N is powered by another 9-volt battery on the underside of the chassis. And there's a power switch between the battery and the motor driver, which I've turned on. So with power on and the sketch uploaded, we should see the servo go through its setup positions. Then after a delay, the wheel should start going forward. Now, if I place my hand in front of the ultrasonic sensor, the car wheels will stop, go in reverse, then start up again when the distance is greater than 20 centimeters. And if I place my hands both in front of the sensor and off to one side, when the car stops, backs up, and checks left and right, you'll see one wheel turn briefly to reposition the car, then the car will move forward, headed in the direction which has the furthest clear distance. So that concludes this video on building an Arduino-powered autonomous obstacle avoiding robot. I hope you found it interesting.